Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to today's webinar, Engineering Smarter Control Systems. My name is Megan Purdy and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them and their cultures and to elders past and present. Before we get started, I would like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Schneider Electric. Schneider Electric's purpose is to empower all to make the most of their energy and resources, bridging progress and sustainability for all. They call this Life is On, and their mission is to be your digital partner for sustainability and efficiency. Schneider Electric drives digital transformation by integrating world-leading process and energy technologies, endpoint to cloud connecting products, controls, software and services across the entire life cycle, enabling integrated company management for homes, buildings, data centers, infrastructure and industries. Schneider Electric are the most local of global companies and are advocates of open standards and partnership ecosystems that are passionate about their shared meaningful purpose, inclusive and empowered values. Now, today we will have one speaker followed by our live audience Q&A, so I encourage you to please send your questions through to our speaker via the chat box. I'd now like to welcome our speaker, Ash Khan. Ash is a technical consultant specialising in open standards, interoperable architectures and IT/OT convergence across mining, water, energy and manufacturing sectors in the Pacific region. With over 15 years of experience spanning engineering, consulting and solution design, Ash helps organisations modernise automation strategies for agility and resilience. He holds a degree in engineering and has been recognised at GovHack and Cisco Live for innovation and technical excellence. Ash actively contributes to industry communities advancing software-defined automation and frequently speaks on modular control, IoT integration, and cybersecurity by design. So please join me in welcoming Ash Khan.
Hello and welcome. Thank you for joining me today. We're going to be talking about engineering smart control systems, and we'll be talking a little bit about the standard IEC 61499. Today's agenda. We will talk about the existing IEC 61131 standard and the 61499 timeline. So when they were incepted and then what are the different revisions that have come out? What are some of the advantages and disadvantages of each? We will then jump into 61499 basics, talk a little bit about what are some of the terminologies and technologies and the processes that are being used in 61499. We will then jump into keeping up with the demand. So we'll talk a little bit more about modern control systems and what are some of the demands of their process and their logic. We'll talk about incremental migration. So how do we adapt new technologies and how we slowly migrate towards modern protocols and processes. We'll talk a little bit about Schneider Electric solutions and what are we doing in this space. We will cover some use cases, and then we will leave some next steps for you to consider, and we'll stop off with the question and answers right at the end. All right, so let's have a quick look at the timeline of both standards. So the one in blue at the bottom is IEC 61131. It was released, or foundation release was in 1993. So it's been there for a very long time, very well matured protocol standard. And there were several revisions since then. So in 2003, they improved the structure and allowed multiple resources in a PLC. In 2013, they reduced the object models, introduced namespaces and XML support. And last revision was in 2025, so it enhanced communications, interoperability, modern automation, and the instruction list for the people who love it. It's been deprecated. On the other hand, IEC 61499 initially started off as trial release with a tutorial tech report, and the official release was in 2005 as a first edition, and the second edition came out in 2012 and 2013. So some of the question people sometimes ask is like, hey, this protocol has also been released for about, I don't know, 12 years or so. Why is it taking so long for it to adapt? Now, one thing is 6.11.31 had a head start, about 10 to 12 years of head start. It became more popular and more adaptable by customers. Secondly, 6.1499 was talking about technologies which were not being really supported at that time. So Linux-based OSs, the architectures for on Ethernet side. So a lot of items were still on serial comms, and also it was the 6.11.31 was heavily pushed by vendors, right? So at that time there was not a lot of support and promoters for 6.1499. But as the time has progressed, 6.11.31 was designed for a specific reason, for automation control. It hasn't been able to expand into the wider requirements of organizations, especially IT/OT integration. It hasn't expanded. There are also some underlying challenges with 6.11.31, which doesn't is not covered in the standard, so it's left open for the vendors to implement, which makes it a bit difficult for customers to choose the software and hardware best suited for the application. 6.1499 was sort of designed for answering to those sort of gaps. And we'll talk a little bit more about it in the next slides. So what are some of the challenges for 6.11.31? It's cycle driven, so it actually scans the inputs, runs the logic, and turns the outputs on and off. It's hardware locked, so typically if you're buying a certain vendor hardware, you also have to purchase that software that goes along with that hardware. The software that we use today, typically you are not able to use it across vendors. So it's a hardware locked, and typically, even if you're moving from one hardware to the other, it requires a lot of re-engineering and revalidation of your code. And lastly is device centric. So when we are using 6.11.31, it typically will start off by using or declaring a certain type of PLC that we will use in our project, and then we design the process, which is a sub-process for that area only. And then if you were to integrate with other systems, there's a level of engineering required for the PLCs to talk to each other, or peer comms, or PLCs to talk to other ecosystems. So what are the disadvantages of cycle-driven? It's poor event handling because it has to run through the whole logic before it comes back to the IO cycle again. Scalability becomes a bit of a challenge. So if you were to add any further logic to our existing PLC logic, the timing and the code has to be revalidated. So it's not efficient in terms of reutilizing the resources because it carries all those IOs across. So it reads thousands of IOs as an example, carries it across, revalidates the logic, and then turns something on and off. Even if something's not changing, it's continuously running the cycle. What are the disadvantages of hardware lock? So modernization becomes difficult. Even within vendors, sometimes it becomes difficult if there's no simple migration path. And then it limits our customers from choosing the best hardware that they need. So typically, if you were to move from one vendor to the other vendor, it's sometimes a rewrite of the code, revalidation of the code. So every 10 to 15 years, customers go through this pain point of revalidating the system, redeploying the system, and so on. Also, the device centricity creates complexity in integration, and it's also very hardware dependent. So that means integrating with existing ecosystems and other PLCs and SCADA systems and HMI is a manual effort sometimes. And it's very, very dependent on hardware. So if I invest in hardware today, I'm relying on it for the next 10, 15 years to keep up with the changing demands that I have in my operations. And it's also a lot of applications or implementation is vendor-based implementations. So they may not carry across. If we were to be changing between vendors, a lot of those implementations may not carry across. So that becomes a bit of a challenge. So what's with the 6.1499? 6.1499 moves away from cyclic scan. It's event-driven logic. So it does do a cyclic scan of the IO, but the actual logic is not executed on every scan. So it's exception-based, which means if something has changed, then the event is or a logic is executed. It's also hardware-agnostic, so it decouples itself from software and hardware lock. And thirdly is distributed or service-centric deployment. So it no longer starts with a device-centric implementation, but it looks at a process as a whole. And then that process could have 2 or 3, 4 different devices running a process. So versus a 61131, in 61499, we design a process and then map it to the best devices for that process, versus in the previous one where we start from a device that we need and then create a sub-process in 61131. So what are the advantages of event-driven? Is high precision. So you get high precision timestamping of your events. It's scalable because if you're changing something in the actual logic, it's only impacting a particular node of the execution, but not the whole cycle. And it's more efficient because it's not overrunning your hardware resources for no reason if not needed. So it will sit on an idle state if nothing has changed. It's hardware agnostic, so simplified migration. So 61499 compliant hardwares can be easily replaced and remapped as needed. So this gives customers the freedom to choose the best hardware as they need, and also reduces the migration cost that they're impacted every 10 to 15 years to move from one hardware to the other. Distributed service centric. It's also the advantage is it's got a native integration between the devices, but it also carries modern protocols for connecting into IT/OT systems. Typically, we'll have MQTT, OPC UA as a northbound protocols, and also do the OT-based protocol in the southbound, such as Modbus, Ethernet IP, and Profinet. Because it supports the Linux and Windows-based OSs for real-time controls and monitoring, it also has the feature of microservices. So the logic itself can run in a microservice or Docker container, which opens up a lot of possibilities for the customers to then run complementary services on the edge, which could be analytics, visualization, machine learning, AI. So it really opens up that door of the IT/OT integration, enabling customers to move forward as the demand changes. So what is event-driven logic? So in a very quick nutshell, we'll compare the two. So in the 61131, read inputs, run logic, write output, and that runs cyclically. So regardless of something changing or not, that's the scan cycle. Whereas in 61499, it has got an event head and the data body or data structure. So if the event changes, then the input is read into the block. The logic is then run, and then based on the run logic, it will write an output and also pass on output events. So because you may be chaining these blocks together, then an event will read the inputs, run the logic, write the output, and then that event output can go to the next block as an example. So if event-based logic execution, so it provides precision with options for value, timestamp, and quality, or VTQs, and efficient use of hardware resource. So it's not overrunning the hardware by running scans constantly. So as we progress forward with 61131, if we increase or add more logic to an existing PLC, it typically will expand or extend the scan time. So it has to be revalidated every single time. So the scaling of logic itself becomes difficult. Whereas in 61499, if we were to add more logic, we typically will add it to a specific function block and only impacts a particular logic node at the execution of that block. So it's not impacting the whole system. Here are some of the basic function blocks or building blocks of 61499. It contains 3 types of function blocks. The basic function block is the core processing block. So on an event, it reads the input, it processes the logic or algorithms, and write the data results to the output, and it triggers output events. So basic blocks are the one that carries logic and executes. Service blocks are interface blocks, which allows us to read and write output, typically physical IOs as an example, and initiate events. So if there's a change in an input, it can initiate an event to run a basic block as an example. Composite block, it's a combination of basic and service block all packed inside into one block. So it can contain basic block, service block, and composite block all packed inside. So it's more like encapsulation of your logic into one single representation. So as an example, here's a function block, which is a composite block, and that's an encapsulation to represent an asset and application, and it makes it portable and modular. So if I was to use this pump logic as an example in my device one, I can then easily remap it to another device and reuse it as an example. Next one is hardware agnostic. So as a picture paints, the device that we invest into today and choose today is locked with us for the next 10, 15 years. That's the life cycle typically on the OT side of things. So sometimes it becomes a drag because at that time it was doing the basic needs of what we wanted to do. But as we move forward, as the demand changes, we find that we have to then build things around it. So we have to buy a gateway, we have to have this middleware or software, we have to give it another drop-in card to do certain things. And it just becomes difficult. There's more risk in carrying extra hardware. You have to learn new technologies, new knowledge base for each individual things that we add along to this hardware that we invest in today. And then down the track, if we were to move from that hardware to another hardware that we choose, there's a level of re-engineering, revalidation required. So 61131 challenge today is very tightly locked between software and hardware. Moving from one vendor to the other it's not an easy task. It's a re-engineering task, and once we do that, maybe because of obsolescence or migration down the track, it requires time and effort and revalidation. So moving forward with software-defined automation, there's a decoupling between software and hardware. So there's an application layer which decouples it, which makes the actual software and hardware unlocked, which also means the investment that I make in my engineering effort on my software, as an example, the logic that I make is reusable and shareable. So I can then easily provide that logic to someone else without asking them what sort of hardware do they have. If they're using 61499, they should be able to reutilize that software or my logic for their application. So this is what we call as a software-defined automation. And that allows us to very easily replace the hardware as we move forward. So once our hardware becomes obsolete, as an example, we can reutilize a new hardware of the same type or better, as an example. But even think about the times of COVID as an example, when we have challenges in supply chain. In that regard, if we didn't have a hardware that we wanted in our spare, we will be able to remap another hardware which complies with 61499 to very quickly deploy it to our operations. This is what we call as the UAO runtime. So UAO is a universalautomation.org. It's an external organization which has multiple members. This enables the runtime on devices which is 61499 compliant. And deploying these onto different devices, as an example, it can be run, a PLC can be compatible with the UO runtime or can have a UO runtime running on it. Or you can bring your own device, as an example, as this particular example shows an ASRock with a UO runtime running on it. So that will allow 61499 logic to run on it. So we have a software called EcoStruxure Automation Expert, which is a IEC 61499 programming environment. So that's where you can create your logic for your process and easily deploy it to any of these devices which are compatible. So these could be Schneider devices, could be ASRock, could be Advantech, could be anyone who has a UO runtime running on it. So that's really the benefit of 61499 with the use of UO runtime. It really unlocks a software hardware lock between the devices and software. And it's not proprietary base. You can see in this particular slide, there are 100 plus sign-in members for universalautomation.org. And you can see some big names on the left side, which in terms of vendors who have joined. So you can see Omron, Schneider Electric, Yokogawa, Hirschman, Honeywell, and the latest one who joined is Anderson Hauser. But there's also a lot of users who are now migrating towards 61499. So you can see some really big names in there too, like ExxonMobil, Veolia, and so on. And startups and institutes and academics are also doing some research and doing some proof of concept using this technology because of the fact that it's beyond just the control system, but because it also involves IT/OT integration and microservices. So you can do a lot more with your hardware. Next one is distributed architecture. So what does that look like? So we talked about composite type blocks representing an asset as an example. So when somebody is doing a bit of a logic construction inside a program, we typically will have different type of blocks connecting to each other, and then we're defining these processes like maybe another valve, pump, and valve on the other side, and this is a single process. This process could be, a sub process or process A and process B, all working as a single thing, but deployed to different devices. So really what distributed architecture is, you design your process and you logically can separate them into process A and process B and choose the best device for that process. Could be a PLC running a UAO, or it could be a Linux device running a UAO, or it could be a variable speed drive running a UAO. You simply map that and deploy it to your devices. So that's what the distributed architecture look like on a higher level or a simplistic level. Next, we will talk about the adapters and intercommunication. These are also defined in 61499 standard. What it does really is it simplifies the events and data into one single structure or an adapter. So it takes the events and data into one single line. And this is what we call a single line engineering, and it actually transmits it across, and then it can be unpacked on the other end for the events and data. So really what it is, it combines events and data into one single line connection. Now, where is it used? It can be used between blocks. So we can use it to simplify our connections between the blocks, but it can also be used between inter-devices. So this allows us to very easily synchronize and connect devices across our process. So if we have a distributed architecture, the adapters allows us to do the intercommunication between devices as well. And it simplifies inter-block and inter-device communication. So if you go back to the previous example, or the distributed architecture that I was showing you, this level of connectivity between the device is handled by the adapter. So there's a level of engineering that is reduced. It makes it efficient because this is predefined. So if we use, as an example, Automation Expert as our software, if we map these devices to device 1, device 2, then this connection between the devices are automatically initiated. So there is no level of engineering required for these devices to talk to each other. So if we were to scale this and look at a bit more on a wider way, then if we have other devices in the network which have dependencies with each other, no engineering is required. These adapters will automatically connect to each other. And if there's other dependencies across the network where devices need to synchronize and connect to each other, they can easily deploy. And these are automatic when we map to different devices, but these adapters a user can define and use as well. All right, so we've talked a little bit about the standard, we talked about the adapters, we talked about how the logic executes, we talked about distributed architecture. Let's talk about keeping up with the demand, especially on the OT control systems. And one of the things that is becoming a lot common is IT/OT integration. What does that mean? It means that OT control systems are no longer just isolated to run a specific process. It's also now there is a demand for it to actually send the data up the chain. And typically, if you were invested into a technology 10, 15 years ago, it will have a very strong OT protocol representation, but probably struggle a little bit with IT protocols. And then we ended up adding like gateways or softwares to support that. So what are some of the IT protocols which are becoming common? MQTT, OPC UA, very well established as IT protocols, even though MQTT sort of started with oil and gas. But that's something that has become very, very common. It's also used with Netflix. I think WhatsApp also uses MQTT as a backbone. Also, HTTP requests or API connectivity is also becoming very common in IT protocols. So these are some of the terminologies. If you were to go and speak to IT people, if you say MQTT, OPC, or API, they will be happy to integrate with something which can talk those languages. Microservices, very common in IT, sort of making its way into OT. It allows you to run other services on the edge or a server, as an example, which could be for analytics, visualization, historization. And if you have any OSs like Linux and Windows, you can run these services. So our software and our offering currently today supports all of this. We will dive a little bit more deeper into MQTT just for understanding of what that protocol does. So MQTT protocol itself, what it stands for is message queuing and telemetry transport. It's a lightweight publish subscribe messaging protocol, and it's designed for constrained devices in the low bandwidth. So it was designed for very low bandwidth and high latency type networks. It's widely used in IoT, telemetry, mobile apps, and IIoT. Very well established and very well accepted. And it can also provide value, timestamp, and quality. So it's not just the value of the information like in the traditional OT protocols, which is just the value at that time of call. It actually provides value, timestamp, and quality, with the edge being the source of the information. We can also do optional device buffering, so store and forward can be implemented. So if the communication is lost, then the data being generated at that time is also stored and backfilled. And really what it helps us is to create a digital backbone for OT/IT. So what we really are promoting is the fabric of MQTT as a backbone, because most IT devices or IT systems will be able to talk to it, but a lot of OT devices and systems are also migrating towards MQTT. So having an MQTT backbone really establishes that inter-device and inter-system connectivity. So what are some of the core elements? And we'll do a visualization of this in a second as well. So there is a topic. Topic is a hierarchy string which sort of encapsulates information or specifies where the information lives. This is where we can use unified namespace or ISA 95 type standards, where you can say factory line 1, pump 1, temperature 1, and so on, which logically represents where the asset is. And then we have the payload itself. So payload can be in the form of plain text, CSV, binary, compact binary, or JSON. JSON being the most common type of representation. But MQTT doesn't hard code what the payload and topic should look like. It's really up to the user what they choose. There's publishers, a device that actually sends the message and the topic. A subscriber who subscribes to a topic, and then, a broker, which is a central server, which is like a postman, if you want to think of it, receives the information and then passes it on to a subscriber. So a subscriber is someone who will receive the message about subscribing to a topic. And lastly, there's a call to service available as well, 0, 1, and 2, which is just to guarantee the delivery. So 0 being send and forget, and 1 and 2 has guarantees of delivery. Sort of like rechecking and hand checking in quality of service 1 and 2. So what does the topic and payload look like? So in a topic, it could be something like this: Acme, plant 1, line 1, pump 1 status. That's sort of saying where the pump is, and I'm subscribed to a status. And the payload, very simplified, can look like that. So I'll have a bit of so that's sort of representing ISA 95 unified namespace style topic. Here's a timestamp, which can be included as part of the payload, some of the values that are associated with that particular topic. And then lastly, we can include the quality. So it's a very simplified way of representing it, but this could be fairly complex or very simplified if depending on your requirement. And here's a quick architecture. So just an MQTT broker in the middle, or a postman in the middle. You have a publisher who's sending the information, like a topic and a payload. And then you've got a subscriber on the right side who's expecting a topic and a payload. So when the publisher sends a topic and a payload update, the subscriber receives the topic and payload. And this could be two-way as well. So it could be a subscriber can also be a publisher and subscriber at the same time, and it can send information back. And if other devices have subscribed to the topic, they will receive that payload. So this can be a fairly complex system if you want it to be. Then we have multiple devices and servers being connected to each other, and each one of them can subscribe and publish to the topic of interest. So really connects, really enables that digital backbone for IT OT systems to talk to each other. Next, we'll talk about microservices in a glance. So really what microservices are is if you have a hardware as an example, a computer or industrial PC running an operating system like Linux or Windows, um, we can run a container engine inside it, and then the container engine contains these applications. So what are these applications? These are microservices, they call them, or micro applications, which can be used for different purposes. So running an application, as an example, you've got different type of flavors out there. So like you can run an SQL Server in there, you can run NVIDIA AI models in there, you can have Anaconda or Python, Grafana visualization, Azure containers, Postgres as an example, or Schneider applications in there. So really opening up the door for customers to take their control systems beyond their just the control philosophy to doing more at the edge. So as an example, these could be the different type of application that you may be running, MQTT, Postgres, Flask app, and as an example in a Schneider app. Internally, it can run a container network, which allows these applications or services to talk to each other and exchange data. And that then can, depending on what the customer is trying to achieve, but you can have southbound OT protocol as an example in the communication. You can have northbound IT OT protocols to your IT systems and cloud. And that opens up the door for really utilizing the IT type services like AWS and Dockers and Google to manage the Docker container and orchestrate those applications. But also with Schneider software as an example, Automation X, where we can also manage the download of those Dockers into the device. Now we understand that in OT environment, not everyone will be across Linux and running Linux commands. So EcoStruxure Automation Expert provides a highly visual representation of customers to use something that they are familiar with, like function blocks, and downloading it to the device instead of running Linux commands to do that. So it becomes easier for the OT operations to maintain the devices without the need of learning Docker container Linux. So it's highly visualized and simplified for OT applications. So hardware and technology choice, a question. So typically in an OT deployment, the expectation by a lot of customers is if I'm investing into a hardware today, I'm expecting it for it to run for the next 10, 15 years. I need a support for the next 10 to 15 years. So in 2020, 2010, if you were have invested in the hardware and also looking at connectivity and capability demand, which is typically increasing, if we had invested into that hardware then, and now we are standing in today, the question is, did it meet the connectivity demands? Did it meet the capability demands in the past 15 years? Or do we have extra hardware and software and middleware that is now hanging off this OT hardware to support the connectivity and capability demand that has been increasing in the last 15 years, and it will exponentially increase in the future as well. So if I was to be investing in a technology today, what are some of the questions I need to ask? Am I going to continue with isolated PLC-centric deployments, or should I be planning for something which is going to be more future-proof? So some of the questions I will be asking myself as an example, is it still OT standard-driven? I need to have something which is OT standard-driven, not something which is driven by IT. Does it allow me to do integration, specifically IT/OT integration? This is a path a lot of customers are taking, and it's inevitably happening. A lot of OT/IT integration is planned or is in the future for a lot of customers. So I would probably invest into technology which allows me to do that. Does it have a option for edge processing? Is it adaptable to change? Is it highly scalable? Does it future-proof me? Does it like down the track, if I were to change my hardware, how easy is it? If I'm investing into my engineering, do I need to reinvest into that in the next 10 years, or will I be able to reuse some of my engineering down the track? So now, if you look at it, OT, yes, in 1993, was the more core focus was running the control system itself because of the hardware and resource availability at that time. It was more focused on that. But today, OT technologies are more than just automation. They're required to do more than just control and monitor the plant. It's required to interface and integrate and provide more context and insight into our wider organization. So if I was to invest in technology, I'll be looking for a device which is more than just that provides an automation. It has to give me more value than just running a logic. So next slide is more about incremental migration, because we talked about the standard, we talked about some of the demands moving forward. The next thing is, how do I change? How do I move forward? Is it a rip and replace? Like, how do I get value out of what we just talked about here today? So I will represent the control system architecture, very, very simplified version of that in a sort of Purdue model. And in my opinion, the best place to start is maybe start from the operations network. So leave the control network as it is, let it continue to run, and complement it and add value to it. And this could be done by introducing, as an example, Automation Expert or IEC 61499 style devices at that layer. Really, what it will do is it will connect to existing systems, not doing any control, but allowing you to monitor and add value to it. What are some of the values we can add? So this is a brownfield process monitoring as an example. It can do asset monitoring and augmentation. What I mean by augmentation is it can take current values from the PLCs, drives, and so forth, bring other information from SCADA and Historian, and you can do stuff like a virtual assistant as an example. You can work out things that the PLC is not working out, virtual flows, virtual pressures, and apply and provide that information to the operator and even to the control systems to make decisions if it wanted to. It can then help with the IT/OT integration out of the box if you were to take that information up north or to east-west as an example. This could be that gelling piece that allows us to do that integration. You can deploy your analytics, enable the AI/ML. You can do experimentation with the data being collected and run the Docker containers on that operation networks to solidify the future and moving forward with IEC 61499. So this allows customers to get the value of 61499 out of the box without interfering or changing control systems, and really get to experience it as we move forward. Next step would be to still not change controls, but we can then go to the edge and sit a device next to the edge of a control system and still do monitoring of that. This can then provide asset-based monitoring augmentation, still IT/OT integration, edge analytics, and AI/ML. The difference now this time is we have deployed a device to the edge. So this is a second phase, if you want to think of it, still doing no controls, but monitoring and making sure that particular process that I'm looking at, I'm providing value to it. And then moving forward, we can then start deploying any greenfield deployments with 61499, because this gives customers the time to really adapt and understand the system, what it can do, and then build the knowledge base that they need to then start deploying and supporting greenfield installations. And as the time progresses and the devices that we were monitoring previously are becoming obsolete, or is it time for migration, then IOs can be migrated across to the 61499. Most IOs, if it's running Modbus or Ethernet IP or Profinet, they can be natively supported and integrated with the existing Automation Expert 61499 devices. And if we have devices which support 61499 on the system, like Altiva Process Drive has a module that supports it, you can also then make those devices smarter and by deploying those modules into those drives. So this become your brownfield upgrade and migration. And finally, if required, the runtime can also be deployed on the enterprise and the cloud deployment side. So that is then sitting away from the operation and control network, providing different type of values to the system, which could be asset monitoring and augmentation of a wider organization, IT/OT integration still, but also integrating the business system and integration. Some of our customers are looking to use automation expert to do integration with their SAP systems as an example. So this becomes that gelling piece on the operation and enterprise level. And on the control network, it can be a transitional piece where you start by monitoring and slowly moving your controls towards the automation expert and 61499. So as you can see, 61499 is not just pitched at a PLC and a control system. It actually provides a wider or a vertical value to the customers, using the standard for not just for control, but for increased value and augmentation and AI ML enablement and IT/OT integration. Now, next slides are more about what are we doing within Schneider Electric and what the solution and innovation look like. So automation expert, I mentioned this name a few different times. This is our unified software experience, which programs the devices in 61499, but we've also got enablement of HMI and SCADA systems. So really what we are moving towards is simplifying customer journey, that they don't have to go and learn 10 different softwares for the SCADAs and HMIs and PLCs and microservices and IoT. We're simplifying the journey with a highly visual software, which is 61499 compliant, and designing and engineering your projects in one single software. So really what it is, it encapsulates a lot of these different things. We already talked about IEC 61499. We talked about IT/OT integration. We talked about universalautomation.org. Some of the things that we have built on top of that is a SCADA integration. So we have a very tight integration with Aviva system platform. So as you're designing your logic controls like pumps and valves and so forth, the visual components can automatically be created for system platforms. So your SCADA engineering reduces. So it's a single effort, but from one single software that can then allow that information to be passed on to system platform for visualization. So all those objects are passed on, and that reduces the engineering time spent on creating a SCADA system. We can orchestrate instantiation of templates in different SCADA systems. As an example, GeoSCADA, if you have templates, we can orchestrate those through MQTT or even APIs. And secondly is the local HMIs. The automation expert has a built-in HMI, which can be deployed on any Linux or Windows type PCs or IPCs. And what we call them is a CAT object. So if you're creating a valve as an example, it has a visual component attached to it, and you simply drag and drop it in your visual experience. So when you're designing this, you simply drag and drop, and it contains all the faceplate that you need for the valve. So out of the box, reduce engineering. When you deploy to the HMI, you don't have to go and engineer and saying, connect with this device and grab these registers. It automatically knows based on the project or where the device lives and what other register it needs to read or information it needs to read from the device. And finally, we also have customization available for the Altovar drives. So instead of having generic displays, we can customize the screen of the Altovar drives to display more process-specific information for that particular process. So allowing customers to have more context when they go and troubleshoot or view an Altovar drive. And finally, the hardware offer. So different hardware is available for different purposes. So Altovar process drive is available with DPAC modules, which can run IEC 61499 at the edge, allowing customers to do more with the drive and run logic and interface with the I/O locally, but also then do northbound communication with IT/OT type protocols. Then we got flavors of different Modicon PLCs for PLC specific type deployments. Essential Edge, which is essentially a Linux industrial PC. And then we also got soft DPACs with any type of flavor of Windows and Linux. So this could be Schneider devices, or this could be third party like ASRock or Advantech. So common engineering platform with automation expert, common runtime across all the hardware, any type of application. So how can Schneider help? We got global, local, and global expertise. You already saw there was a big sign up of universalautomation.org. So not just within Schneider, but the community is wider across vendors and users. We also have certified system integrator channel, which can help you with your first deployment and support you with the life cycle of the deployment. We have training and support programs available. So if you're needing any training or support or workshops, please reach out. And then we got consultation, project, and trial. So we are happy to engage with consultation, sitting down to discuss your projects or any business challenges that you have or operational challenges that you have that you wish to discuss and see that we could solve. We'll be happy to discuss that with you. Next is some use cases. So Vanilla Dome, some of the needs and challenges for the customer. They wanted remote visibility, remote operations, future-proofing their installation. They wanted a cookie-cut repeatable design, quick build, quick commissioning, low operating cost, resource optimization, energy management, and ease of use. This is on a very high level what it looks like. So we have got some IOs coming in terms of environment and hatchback control. Automation expert sitting in the middle, receiving that information, sending that information to an IoT cloud platform over API for visualization for customer, and then EAE local HMI for visualization. We also deployed it to our robots at Clipsal Jeffs which actually manufactures the general purpose outlets or GPOs. So they were using a lot of legacy hardware and non-native HMI, a lot of legacy protocols. There was a lot of custom code, and they wanted like ease of maintainability. So we interfaced with the existing robots and cameras. So camera feed were converted into digital information of quality checks. These were then ingested into automation experts who then run the robots, run the actual process, and then provide a more modernized SCADA HMI locally, and also interfacing with the plant SCADA HMI that is deployed on Jeffs Cross. Next one is remote pumping. So this is a simplifying hardware to support control, local SCADA, and machine learning. The customer challenge was they had multiple devices to do that. They wanted a simple architecture, which can be easily modernized. So for Greenfield, they're looking at industrial PCs only to simplify their single hardware to do all of that. And with the existing installation, they're looking at a hybrid approach for like interfacing with PLC. So pump station, automation expert running the logic, also providing IT and cloud connectivity remotely, and also having a local HMI and a SCADA client running locally on the same hardware. Simplified application for protocol gateway, so reduced traffic network. So previously there was the customer, what they were using, there was a lot of noise on the network when they were collecting information from the devices. So they wanted something more modern protocol like MQTT, more based on exceptions. Low-cost solution, simple hardware, can be easily deployed in the brownfield. Reusable engineering, so they can reuse it multiple times and centrally managed. So in this case, we're looking at power meters, interfacing with the automation expert device, and then visualizing on the SCADA and HMI. Remote monitoring, very similar to the previous one. So monitoring remote asset, integration to IT systems, using IoT protocols, simple scalable solutions. And this was more monitoring the generator, HMI, power systems, and battery systems, bringing that information in and then converting that information to IT protocol to be displayed. Mining application for heavy machinery interface. This was more around interfacing existing information on a PLC that can then be help enrich the information on the vehicle monitoring systems, which is for fleet management. So they wanted information of the actual process going into the fleet management to make some decisions. So EAE was used in between to grab the information from the PLCs and then provide it to the fleet management platform to make more insightful decisions. Virtual operator, this is an interesting one. So this is more for deploying on a brownfield site, where this could be used just for monitoring of your existing process. What it does, it can look at your pump statuses, tank levels, and flow statuses, bring it into the automation expert, and we can do relationship checks of different assets like valve, pumps, and so on, just to make sure that the actual statuses and the levels of those assets is correct. So if the valve is open and the pump is running, if the valve is closed and the pump is running, and another valve is closed, it can do a complex relationship evaluation and give more insight around if the process network that you have for your application is in the correct state or not. But it can then also do predictions. So you can take values from your flow meters and tank levels and use that to calculate theoretical values of flow in different network of your piping, as an example, for water, which can provide more information than just the flow meter. So if you lose that flow transmitter, as an example, or level transmitter, you can use the theoretical values as well to make some decisions. Hydrogen plant. Again, this is more for control, for OD operations, required local HMI on hardware, simplified engineering, modular reusable code, utilizing the libraries that are provided by Automation Expert, build new and able to build your own new library, and then also central management. So in this case, it was more pump, tank levels, and flow, running the control logic on Automation Expert, and providing a local visualization. Biogas plant, very similar to the previous one, running your pump levels and flow within Automation Expert and providing visualization. And finally, automated IO testing, which was an interesting use case. This is more going beyond this control systems. This is for complex IO testing requiring simplified solution. I really wanted to import the test procedure in an Excel's format into Automation Expert, and then validate the IO testing, and then give a report. So really what it was connecting to existing IO system into the IO interface. Automation Expert will have a list of things to check, and then provide a local visualization, but also provide a report at the end. IEC 61131 has limitation in meeting demands of modern architecture. IEC 6149 offers scalable, hardware-agnostic modern architecture. OT operation needs future-proof, flexible, and open architectures. That's the new demand. You can add value to your existing control system with an incremental migration plan. And finally, modern OT is more than just automation function. There's more required now for the OT systems to do than just control. So in summary, functionally, if we were to continue, we would have never moved from horses to cars and telephones to mobile phones, or candle to a light, or a cassette tape for people who still know what that is, to iTunes as an example. Or moving from legacy PLCs to modern protocols and standards. So what are some of the next steps? Review challenges with your current state of operation and site standards. Review current and future needs of operation, including IT, OT needs. And please reach out and engage with us. We have a Center of Excellence team which can help consult and sit down with you to discuss your project needs. And that brings us to the end. Thank you very much. And the next slide is more around Q&A. So we'll open the floor for Q&A. There are a couple of QR codes. If you have any inquiries, scan the code on the left. If you're looking for more information on IEC 61499 and Automation Expert, scan the code on the right. Thank you very much.
Thanks so much, Ash. What a great presentation. Well, now it's time for our audience to get involved with our Q&A. A huge thank you to everyone who submitted a question while registering for today. So what I might do, we'll bring Ash in, is kick off with one of the questions that we have here. And it is, so hi Ash, it is how can engineers start integrating IEC 61499 within existing infrastructures to unlock performance gains step by step?
That's a great question, and I think one of the slides we sort of talked about earlier, it is something that is not like a rip and replace technology. It's a complementary technology. So really, what we need to look at is what are some of the challenges that we have with our existing control systems? What are some of the things we're trying to achieve to provide more value to the business, and how we can use IEC 61499 to actually complement that. As we saw that it can have support modern protocols, so it could be just about unlocking the data from the edge. But because it also supports microservices, you can then deploy edge-based services to do insights or machine learning. We also saw that IEC 61499 is not just a PLC. A lot of people confuse that as it's a PLC to PLC replacement. But as we saw in the architecture, it can actually sit at the edge layer, but can also sit at the operational layer. It can also sit at the enterprise layer. So depending on the challenges you're solving, you can host IEC 61499 in different layers of your Purdue model, as an example, and solve that challenge at that level. And because it can scale and because it can complement different layers, as you move forward, a lot of our customers, they start off with a journey and they say like, hey, now I understand I can actually now deploy it there and I can go to this PLC or I can go to the business systems. So the possibilities are it's really about your creativity and your imagination where you can apply the possibilities. So start with something which has a business value. That will be my recommendation. The challenges you're solving, not something super easy, not something super hard. Pick something that is is a little bit of challenge to implement, but also provides a business value at the end. So that will be my answer to that.
Awesome, great advice. Well, the next question came through live, so I'll jump into some of the live questions because we had a few come through. And this one I think came through from Johnny, and is what is the uptake of IEC 61499 versus IEC 61131 at this time?
A great question. So I think one of the slides we presented was around the UAO membership. So you can see globally there's 100 plus members signed up. I think about 40 plus are vendors, and there's about 50 plus which are customers. Now, these are the people who have signed up. Doesn't mean these are the projects that we have done with these 50 customers. These are the customers and vendors who are really interested in driving the standard forward and what it will look like moving forward. So globally, Schneider Electric has done multiple projects with mining, water, food, and bev. And the interesting part again is they're not just PLC projects. Some of these projects are like IoT integration, edge-based processing. They wanted to bring in 61499 to solve some of the control system challenges, but also to go beyond. So for myself, it's a transitional piece, and I think the uptake has been really, really promising. Just like any other technology, there's a transitional piece. There's a level of education in the market, and in OT, we're not really known for like the innovators, like the people who really pick up technology very quickly. OT customers typically take their time to adopt to technologies. But now is the time. So we've seen really good uptake. People are starting to see the actual value of what 61499 can provide. And again, like we within Schneider, even in Australia, we have a center of excellence team. So if there's anything that triggered like, oh, maybe I need to know more about this stuff, or I feel there is an application for me, we're here to engage with you and consult with you and really work out that solution. That we're not going to try to force a product to a problem, but we want to bring the problem to a solution. So we have an experienced team here in Australia. Feel free to reach out.
Awesome, thank you. The next one, which came through from David, who's watching live, so big hello to David, and it was around, well, kind of going on from the topic, I suppose. How do you see the uptake of 61499 by traditional automation vendors that will lose a significant marketing revenue stream by making software universal and hardware interchangeable?
That's a great question, and I think there is no doubt that the approach is disruptive. I would say it's constructive, not super disruptive. Uh, but really, what we need to think about firstly is we need to think about the customer. Customer should be at the center of what we do. What do our customers want? They want freedom, which means they want flexibility and systems that are standard driven. That's the first important thing. So I feel once this standard is going to become more and more common, people, especially customers, will push for it because they will see the freedom and the choice that they have to choose the best hardware and simplify the software experience as much as possible. Now, again, part of that is the question was more about what will happen to the vendors who are currently working in that paradigm of which, not by purpose, but a lot of time it is locked with software and hardware. It's a UA open standard, so everyone has a freedom to join the group and be part of it. So we already saw like Omron, Yokogawa, Honeywell, Schneider Electric, and there's Hauser, which are some of the bigger players in OT already part of that standard, and they're already now in the part of developing software and hardware for it. So it's not locking down any vendors. Sure, some vendors will wait for the things to sort of spike up and then they will join when the wave is high. We like to be innovative. We want to be part of the wave earlier. We want to create those waves in the market, and really we customer focused. So we want to make sure that we're providing to customers, future proofing them, making sure that it actually complements existing process, give them the efficiency, and really it helps them grow their business.
Excellent. Thanks, Ash. Great answer. Just moving on with the live questions. So the next one was not quite sure who it's from. It's a bit of an interesting tagline, but they're curious about how emerging standards influence the interaction between mechanical and control design.
Yep, excellent. That's a great question. So the mechanical systems, if I'm getting this question right, I'm assuming the things that we are probably controlling, like maybe pumps, or could be vents, or could be HVAC systems, lifts, whatever that might be, that continues to be unchanged. So these are the endpoints of a control system. Modern control systems, even IEC 61499, will help you integrate with your systems seamlessly as they were before. Just like we sort of talked about the Calypso Jeps Cross factory that we upgraded, it was endpoints for our robots, which were doing molding the faceplates on a manufacturing line. And as an example, we simply interface with them very similarly based on the previous control system. The standard actually improves the internal processing of the logic. So it's event-driven. It provides you with the timestamp. It will provide you with the quality, but then also helps you then interface and make the data available very easily to the other systems. So previously, there was a lot of engineering involved to get the data across to other systems that we needed. Now it's sort of out of the box. So mechanical systems remains unchanged till there is something revolutionary happens on the mechanical side and they come up with a different type of protocol. Then the other vendors, like the control system suppliers, will have a driver to talk to those sort of systems, as an example. So the short answer is, I would say no change. It's actually a control system philosophy change, but not the mechanical sides.
Awesome, thank you. There was a question which came through from Les, and it was, can runtimes be updated in real time without taking the process offline? And then it was, if there is an error, can this be rolled back?
Great question. So because IEC 61499 borrows from 61131, so whatever that 61131 does, we do it better, I suppose. It sounds a bit of a salesy pitch there, but that's true. So we can still do online changes just like we could do in the traditional PLCs. The major difference here is there is a boot project, we call it, and it's a current running project inside the PLC, as an example. So we can go between dev and production real time as well. So if we were to then keep a backup project inside the PLC and roll back immediately, we can do that as well as part of the actual deployment. Online changes still available. And if you have standard driven stuff, like if you have assets that you roll out as you progress forward, you can also pre-plan those changes. You can pre-deploy those assets in your PLC as an example, and you can trigger them from external systems like HMI and SCADA to instantly roll out your changes online for those assets to be binded to the IOs, and then also talking back to the SCADA system. So yes, whatever we can do today with the PLCs and DCS, we can do with 61499 and more.
Cool, thank you. Well, the next question is, in a SCADA and PLC environment where the edge layer and OT connectivity are typically handled through pre-configured SCADA systems, how can automation engineers practically employ microservices?
Excellent. I assume this is maybe asking, can we manage microservices from SCADA system? Apologies if I get the question wrong. So today, the EA runtime microservice is deployed through the build time of the software. We are looking to provide that Docker as an example, or the container as an example, as a downloadable piece, which means it can be deployed by a SCADA system if that's your central area where you want to do your engineering and deploy it to the end devices. But then that also means it can be deployed by any microservices type orchestration tool. So I assume the question was asking that. If not, feel free to reach out, and I'll answer that to the best of my knowledge.
Awesome, good on you. Thanks, Ash. The next question came through from Gavin, who is watching live today, and I like this question. It's interesting. It's one of the ones that I've seen a little bit of chat, and I'll just get to it. What consideration does 61499 have to things like 62443 cyber and 61508, 61511 functional safety? In practice, end users have a lot of entrenched reluctance to converge due to risk appetites.
100%. That's a great question. We have a couple of certification for the 62443 secure by design. We also have a functional safety certification as well with the TOB. I can't name the exact one which we've got, but we got those certifications. In terms of the implementation of the technology and how we architect it, 100%, like 10 15 years ago, when we were having conversation with customers about cloud and edge analytics, it requires external comms and all that stuff, the doors were closed. Like, the risk appetite was just not there. It's now opening up, and a lot of customers that I have worked with in water industry and mining industry, they now have a checklist, painful checklist for cybersecurity, but at least there's a checklist, there's a guide that you can pass as long as you comply with it. So typically those questions will be around, where is the data hosted? Is it in Australia? What sort of encryption do you use? Like, what protocols are you using? If using MQTT, are you using TLS 2.0, TLS 3.0? They will have those requirements. So, and it's great because I think cybersecurity should be at the forefront for the vendors and the end customers. So with these sort of requirements, really what it is, you consult it through and see where the data is going, where the data is going to land. If the cybersecurity practices are in place, those doors can be open. And I think it's more about working with the customers around what the requirements are, what the concerns are, what are they seeking, and there's a level of consultation that may happen. But I find it's a lot easier today. Well, I won't say easier, but it's easy today than how it was 15 years ago when we were having this conversation with customers.
Thanks, Ash. Well, the next question was around, what is Schneider's application of OT in the solar industry?
Great question. So we had a slide on one of them. I won't say that was a solar solution that I presented in my slide, but it was more around showing the interfacing with the power meters and the information coming from the chargers and so forth. Globally, I think they have done some projects on it. Locally, I don't think we have done like an end-to-end solar project with a customer at the moment. But because we already know that the existing solar project or best projects typically have an IPC and a PLC at the edge doing the controls and monitoring, we can do similar. So edge devices which can interface with inverters and other field devices very easily, typically they talk Modbus. Then we can send the data back to the SCADA system choosing your own favorite protocol. We would recommend go MQTT if you can. So those solutions can be very easily built. The automation expert, as an example that we talked about, is not specifically designed for a specific vendor. It's for all type of applications. So really what it is more about engaging and seeing how this can bring more value to what you currently have.
Awesome. Thanks, Ash. We did have a question that came through from Greg, who's watching live. So a huge, big hello to Greg. Pretty straightforward question. Can Automation Expert be just a migration tool, or is it for permanent deployment?
I think it is typically it's a permanent deployment. So it is designed to go and deploy and either control your existing control your assets, or complement with the existing control system and do some monitoring and provide some more insights. So typically it's going to be a permanent deployment in most cases, unless it's being deployed to do some insights for a certain area for 6 months, as an example, and you're doing some, I don't know, deep packet inspection, well, not even deep DPI, but I would say like if you're monitoring your traffic, because locally in Australia, we have developed some engineering tools within the Automation Expert that can then look at the commands being sent by different device or assets to run a pump, as an example. And then you can look at the MAC addresses and see who's running which sequence, and then you can sort of stop them or allow them, or have a bit more better insight into what's talking to what. But typically that's a permanent deployment, unless there's a use case somebody wants to plug it in for a little bit to prove something or something like that. So typically permanent.
Awesome, thank you. And then we had a question around, how do you see the role of edge computing evolving in smarter control systems, especially when balancing local decision making with cloud-based analytics?
Great question, and I think that's a question that gets asked a lot of time. Sure. So I feel the edge computing brings a great value for the control systems and actually doing some more insights and making decisions at the edge layer. It's slowly getting there with a lot of customers because, again, OT customers are very driven by the existing or traditional control systems, and they sometimes have challenges in deploying a hardware in the field because they don't have any space left, especially in remote sites. And in other areas, it's more about the knowledge base. So because it's a new hardware, requires a new type of knowledge. Sometimes people are scared of change. Like that's how people are. But in terms of edge computing evolving in smart control systems, it brings that value. So for me, it's more about the knowledge and the wisdom that customers have within their install base. Edge computing can make those decisions, or at least provide insights on those information to an operator with more insight. As an example, an operator might be looking at his SCADA screen, looking at 10 different alarms popping up on a screen, and then he's looking at a trend. After 1 day of analysis or 2 days of analysis, looking at multiple trends, they will like, oh, I know why this failed. And person with a lot of experience, with 15 experience and experience, will say, I can see the pressure drop and that sort of vibration went up and those sort of things. And yeah, now I know why it failed. But it's too late. You can do the analysis 2 days later and you can tell why it failed, but we couldn't stop the failure at that time. And how do we do that? We can then have these models that can be trained living at the edge of the device. Some customers may not be comfortable with the models doing the control. No problems. Provide the information back to the operator and keep human in the middle. But at least you can have those complex information being evaluated by the edge device if you want, and provide that instant information to the operator to act on. Now, in terms of cloud, typically when you're moving away from the control system and going to the cloud for analytics, there is a decision latency, and really depends on the asset criticality and how quick do you want to respond to it. Typically, you'll move to cloud is because one reason is you weren't able to deploy an edge device, and the cloud is the way to go. And second thing would be you may be running something really complex, which requires a lot more processing, and then cloud is the way to go. The only difference between the two, from my experience, would be just the latency. start with whichever it's easier for you. So if you want to start at the enterprise level or the cloud level, it's a lot sometimes easier to deploy there because you have room, you have IT people typically looking after it. They'll be more open for stuff like Docker containers. The thing will be the DMZ and going into the OT and then grabbing information. Again, like your data sources preferred. My preferred will be to go to the edge and grab the information at a higher frequency if you can. But if Historian is available, start with Historian. Gives you that first step towards going, moving towards just the reactive control to doing something more proactive. So start with whatever's going to be easier, checks off the cybersecurity checklist, and then you sort of stage it forward as you start to prove value.
Awesome. Thanks, Ash. Look, we are starting to get to the end, and I did want to pose two more questions for Ash, and then I think we can give him a break. He's done a brilliant job today. But one of the questions came through from Richard Bowyer on registration. I thought it was a really good question because we do get a range of engineers in the audience. So the next one was: the current generation of workers in the engineering sectors are facing an increasing demand to reskill and upskill as technology evolves to meet society's needs. Could you please comment on Schneider Electric's view, policies and activities on skills development of our next generation of workers?
Excellent question, and something that which is sort of dear to me as well. I like mentoring and giving information to the next generation, coming forward to the technology area. So for me, it's important that I share that knowledge. Knowledge not shared is knowledge lost. So Schneider Electric runs a annual grad program. So there's a 2-year rotation where we bring in the students from engineering. Yes, typically it's engineering discipline. And after those 2 years, they will typically stay with Schneider and continue their career, or sometimes they move on and then they want to do an experience somewhere else. Two of our experts in the automation expert team were grads at one point. So they finished their grad program and they were offered a full-time position within Schneider. And I learn from them every day. They know a lot more than what I do. I just talk more high level. They know the actual what's happening in the device and how to do the programming. So I really appreciate, and I can really see how the graduates actually absorb the knowledge and actually can bring in that extra information. Sometimes you get blocked out with your experience, but they bring that wider view of that. We are also involved in some of the STEM programs like Try Engineering and Crossroad, which is more about early engagement with the students, supporting the career path, also about the diversity of the workforce coming through, and making sure that they're future ready. Personally, myself, I engage with a lot of universities as well. So locally, I work with Griffith a lot. We have a SCADA lab that we set up with Griffith. We've got some RTUs there. We had some basic smart relays there as well. And I'm currently engaging with them to see if I can also deploy the IEC 61499 lab there. And I'm in talks with that as well. On the west side, Edith County University is someone that I have worked very well as well. They have got a Schneider lab there too. Excuse me. There too, which has got our PLCs, RTUs, radios, SCADA systems. So it bears the fruit because I started working with Griffith, I don't know, I think 10, 15 years ago, and we deployed the lab, I think 5 years ago. So I saw those students who started their journey as a first year grad to then finishing their graduation, and then they're now actually working, and they're like our customers now. And it's probably because they learned the OT technologies, which were very relevant to the people who are hiring them in the field. So a lot of our SIs and end users will say there's a gap, and how can we minimize that gap? I personally get involved as much as I can to work with the universities to make sure the teachings are relevant in terms of the industrial protocols and things that they will learn, like ladder function block structured text for 61131-3, but also now learning IC 61499 function blocks, and staying ahead of the game a little bit. Whatever we learn today is obsolete tomorrow. So it's always about engaging and providing information to our educational partners. I also worked with SkillsTech at some point with engagement in Eagle Farm. We set up a lab there as well for the for the trades people. I've worked with universities in the north as well. So yeah, personally for me, I love that engagement, and I try to provide whatever I can from my end, making sure the students get the best of the information that we can provide. And then yeah, so that's I hope that answers the question.
I think it has. Thank you. That's excellent. It's wonderful to hear the engagement with industry and the tertiary sector working together. So it is great to hear. And then I totally agree. It's definitely to the benefit of industry. So our final question today is, what advice would you give to organisations or engineers beginning their journey towards standards-based, event-driven automation?
Excellent question. And I think a lot of time, especially when you speak with engineers, we sort of go down the path of technology and solutions and what's best out there. And I think it's important that we align towards what the goal and vision is for our organization, and what are we trying to achieve? What are the challenges do we have today, and what business value is realized if we solve those challenges? I think we have to start with the problem. We have to start with the challenge, and then work from there to what the solution may look like. So the true value is realized when we prioritize and articulate challenges we need to solve. So the first thing is we need to make sure that we can articulate our challenge. We know what we will get if we solve this challenge. It's also not just about the technology, it's also about the people, because remember, when we introduce the technology, when we bring in the technology into an organization, we must be very careful what we choose, because technologies can upgrade with a single click of your mouse, but getting people through that journey and then upskilling your people is a very important piece. So that needs to be planned. So bringing people should be part of that journey and driven by the vision they aspire to achieve together. So that's very important. Also, having the innovative mindset is very important for everyone, like end users, as system integrators, vendors. We need to have that open mindset about, think big, start small, go fast, fail fast, and learn, and then improve from there. A lot of people are like waiting for others to, take on that risk, or, we will wait for 20 years for this technology to become obsolete, then we will adapt it. Those sort of conversations. So I think a lot of organizations, especially like Schneider Electric, we invest heavily in innovation and train people into really that sort of thinking, where we start off with the customer experience and work backward from there. That's very important, like the challenges of customers, and work backward from there. Finally, let's talk about technology, what to choose. Now, if I was a customer and if I were to choose a technology, I think the first thing, especially in the OT, will be it needs to be standard driven. I don't want something which is proprietary, or somebody written a code in Python and then that person leaves tomorrow, then I'm in trouble, right? So I need to have something which is standard driven, future proofs me in terms of, if I'm going to invest into this technology and I'm going to create logic and everything else for this particular technology, I want this to be protected. I don't want to lose this in 5-10 years time and redo it again. It's like, writing a piece of Word document, and then once you upgrade your Windows, like all your Word documents are no longer valid. You need to rewrite your Word document. Like, how would that feel on the IT level? Like, it will feel really bad. Why do we accept it in OT? So I think that thinking should change, that you're investing into engineering, you should be able to protect it and move it forward. And also something that I will invest is, which is something that is supported locally and globally. So don't want to go and get a technology which nobody has a knowledge base on, unable to support me locally or globally. And I think that's very important. So regardless of whichever technology any customer chooses, I think these will be the three things for me. Like, it's standard driven, it's future proofing, and it's locally and globally driven. Like, there's a knowledge base on that. So connecting it back to what we do, we've got a local expert center of excellence in our team, which is specifically for the automation expert in 61499. Globally, we've got hundreds of employees who are working in 61499 within Schneider. Let's go outside Schneider. You saw the slide, you had 100 plus members. So that means the knowledge base is not just Schneider driven. It's actually, you got big vendor names in there, big customer names in there, a lot of educational institutes who are already doing research, and not just research, because a lot of people think it's a research-based project, but they're doing some cutting-edge stuff with the 61499 standard. So that will be my takeaway, that people, process, technology, find a way to move them together, keep the innovation hat on, invest into the technology, which will help you move forward.
Oh, look, great advice, Ash, and what a perfect way to end such an interesting session today. So, look, that's all the time that we have for our webinar today. Please join me in thanking our speaker, Ash Khan, for his time and input and passion on the subject. It really was very interesting, and I can see all the chat coming through. Everyone has really enjoyed it. So there were a couple of questions, and yes, this video is available. It will be on our Engineers Australia YouTube page, so please check it out and definitely share as required. I would like to take the opportunity to thank Engineers Australia's industry partner, Schneider Electric, for their support today. And finally, if we could, we would appreciate if you could take a moment to please complete the short feedback form, which is found in the description box below. As always, your input it really does help us to improve and plan our future sessions for you. So finally, thank you again for joining us today, and we look forward to seeing you at our next Industry Partners event. Good afternoon.